Assalamu alaikum, dear students. In this lecture, we are going to introduce calculus and we are trying to find answers to few questions like what is calculus, what do we need, why do we need to study calculus, and what type of problems can be solved with the help of calculus. So let's see and find the answers of all these questions. So first of all, what things could be considered the greatest achievement of the human mind so far? So there are a few things. Let me show you. So there are few things that can be considered greatest achievement of human mind. And do you know that all these things emerged because of technological advances? And those advances, in fact, relied on calculus. Calculus has made it possible to build giant bridges, travel to moon, and to predict patterns of population change. So there are two statements in front of you. First statement is, studying calculus is hazardous to your health. Second statement is, calculus is totally irrelevant. So take a while and think whether these statements are true or false. Well, let me tell you that both the statements are false. Studying calculus is not hazardous to your health, and calculus is totally relevant. Well, genius of calculus is very, very simple. It relies on only two ideas, the derivatives and the integral. So both come from common sense analysis of motion. So what is motion? Motion is change in position over time. And in order to see the motion, all you have to do is drop your pencil to see it happen. So there is a question, what is calculus then? It is mathematics of change. So whenever we have to study change in any phenomena, we need calculus. It is the mathematics of tangent lines, slopes, areas, volumes, and it enables us to model real life situations. So this is relevant, very relevant to real life. And it is dynamic. It is not static like algebra or pre-cal. Well, we can answer the question in another way, that calculus is a limit machine. It involves three stages. First stage consists of pre-calculus and algebra mathematics process, that is building blocks to produce calculus techniques. The second process is limit process. And this is actually the stepping stone to calculus. And third, the calculus, the branches of calculus we are known with, that is differential calculus and integral calculus. There are more answers to this question. Calculus can also be thought as a systematic method for solving problems about systems that change. Calculus is a language for describing dynamic systems. Calculus is a collection of ideas based on infinite processes and limits. So let's compare the problems, real life problems without calculus and with calculus. So how without calculus we are limited to solve some problems, and calculus actually gives us the liberty to solve the wider range of problems. So without calculus, we use fx to find the height of the curve at any point C. Whereas with calculus, we can find the limit of fx as x approaches to C. Fx here is function which depends upon x. Well, without calculus, we can find the average rate of change between time A and time B when a car is moving from a point A to point B. Whereas with calculus, we can find the instantaneous rate of change at time C. Without calculus, we can find area of rectangle. We can find area of any proper regular shape. But with calculus, we can find areas between two curves. That is, we can find areas of irregular shapes as well with the help of calculus. So, with calculus, we can find slope of line, and calculus helps us find the slope of line even when the shape of the line is always changing. That is, it helps us finding the slope of curve. But without calculus, we can only find slope of line. So with calculus, we have pre-calculus formulas like slope of a line, average speed, area of a rectangle. But with calculus, we have calculus formulas, that is slope of a curve, instantaneous speed. Instead of average speed, we can find instantaneous speed in calculus. And instead of finding area of rectangle, we can find area under the curve or area between the curves. So this tangent line problem is a very important problem in the calculus. So in order to approximate slope of tangent to a curve, we start with slope of secant line of the curve. And slope of this line can be measured by this formula. And in limiting case, the slope of secant line becomes slope of the tangent line at this point. We'll study all these concepts in the next lectures. Well, there are area problems which can be solved with the help of calculus. And in these problems, we seek the area under a curve of the graph of the function fx. And we approximate that area. This is actually the area under the curve. We approximate that area with a number of rectangles. And the approximation is improved by increasing the number of rectangles. So this is another problem which can be solved with the help of calculus. There are several other things calculus can do. So let me state few of them. It explains why the angle between an observer and a rainbow is 42 degrees. It connects designs on a laser printer to form letters of arbitrary size. It helps find the best seat in theater for viewing a movie. Yes, it can also be done with the calculus. Well, the relation between velocity and position is given precisely in the language of calculus. Similarly, Newton's second law of motion is accurately and precisely described in the language of calculus. The language of calculus shows that the relationship between velocity and the position is same as that between force and momentum. The same calculus can be used to determine trajectories of airborne bombs and missiles. So, the basic ideas of calculus are limits. And the idea of limits actually leads us to the major branch of calculus, differential calculus. And limits also help us in another major branch of calculus, which is called integral calculus. And in order to study all these ideas, we need to learn functions. So in next lecture, we'll define functions, and we'll see properties of functions and domain and range of functions and everything related to function, graphs of function, etc. So that's all for today. See you next time, inshallah. Take care. Bye-bye.